Hey everyone, and welcome to The Explainer. Today, we're going to pull back the curtain on the invisible magic that connects pretty much everything in our digital lives. We're going to break down how computer networks really work from the ground up.
Really stop and think about it for a second. You click on something, a whole web page just appears. You send a photo from your phone, and poof, it's on your friend's screen halfway across the world. How does that actually happen? So fast? So reliably? Millions of times every single second?
Well, it all starts right here, in a space you probably know really well. This is a local area network, or what we call a LAN. It's what connects all the devices in a small area, like your house, your office, or a classroom. This is our foundation, and over the next few minutes, we're going to build out from this simple picture to see how the whole system works. All right, first up, let's get the essential pieces on the table. What are the key bits of hardware you absolutely need to get all your devices talking to each other?
First, we've got the router. You can think of this as your network's official gateway to the outside world. Its whole job, really, is to connect your private local network, your LAN, to the massive public network we call the Internet. It takes all your requests, sends them out, and makes sure the answers get back to the right place.
Now, inside your local network, that's where the switch comes in. And this thing is like a super efficient traffic cop. If you've got a bunch of wired devices, desktops, game consoles, printers, they all plug into the switch. And when one computer wants to send something to another, the switch doesn't just yell it out to everyone. Nope. It creates a direct, private line just for that conversation. It's smart, and it keeps things fast.
Okay, so let's put it all together and see what a typical setup looks like. You've got your wired stuff, like your desktop computer, plugged right into the switch for super fast internal chats. Your wireless gadgets, like your phone, connect using a Wi-Fi access point. But look closely. Both the switch and the Wi-Fi point feed into one device, the router. And that's the key thing to remember. The switch manages the traffic inside your home, but the router is the one and only gateway to the outside internet.
Okay, so we've got the gear, now what? How do we actually, connect it all together? Turns out, the shape or the layout of your network is just as important as the parts themselves. This is the blueprint.
And in the networking world, there's a word for that blueprint. It's called topology. It's just a fancy term for the pattern you use to connect everything up. And just like building a house, the blueprint you pick makes a huge difference in how well everything works.
So this slide really shows a tale of two designs. On the left, you've got the old way of doing things, the bus topology. Think of it like a party line phone call. Everyone is on the same single cable. It was simple, sure, but data would constantly crash into each other, and if that one main cable broke, the whole network went down. That's why today everything uses the star topology on the right. Every single device gets its own private line to a central hub, which makes it way faster and much more reliable.
And this table really lays it all out. Yeah, the bus was cheap and easy, but it was also slow and super fragile. One break and you're done. The star costs a little more because you need more cable and that central switch, but the payoff is huge. It's fast, it's dependable, and if one computer's cable goes bad, who cares? Everyone else stays online. And that's why basically every modern network you'll see today is built like a star. All right, so our network is physically built. We have the hardware, we have the layout. But how do all these different gadgets from all these different companies actually speak the same language? The answer is a set of shared rules or protocols called TCP/IP. And you can just think of this as the universal language of the internet. It's the whole reason it all works. Without it, your iPhone would have no idea how to talk to a Windows PC, and your computer could never get a web page from some random server across the world. TCP/IP is the magic handshake that lets everyone talk to everyone else. So, how does this language actually work? Well, when you send something, like an email, TCP doesn't send the whole thing at once. Nope, it chops it up into these little pieces called packets. Then, each tiny packet gets stamped with the destination address, just like putting an address on an envelope. Those packets are all sent out, and IP's job is to get them to the right place. Then, at the other end, TCP's job is to put them all back together in the right order.
And this right here, this is what makes the internet so brilliant. It's called packet switching. See, your data packets don't have to stick together. They can all take different routes to get to the destination, just like a bunch of cars taking different highways to avoid a traffic jam. And what that means is, if one path gets blocked or cut, the data just finds another way around. It's what makes the internet so incredibly resilient.
Okay, our network's up and running, data is zipping around, but we all know the internet isn't always a friendly place. So, the next critical step is security. We need to put up some walls.
And your very first line of defense is the firewall. The best way to think of it is as a digital security guard standing at the only entrance to your network. It literally inspects every single piece of data trying to get in or out.
And based on a set of rules, it decides you can pass or nope, you're blocked. It's essential for protecting you from all sorts of nasty stuff out there.
But you know, a firewall is just one piece of the puzzle. A huge part of security is also on us, the users. And one of the simplest, most powerful things we can do is just use a strong password. The rules are simple, right? Make it long, mix it up with letters, numbers, and symbols. Don't use your name, and switch it up now and then. It just goes to show you the best security is always a mix of smart tech and just smart habits.
So, even with the best setup and top-notch security, things can still get, well, messy. Data doesn't always travel perfectly. So how do networks deal with the little errors that are bound to happen?
See, the digital world is all just ones and zeros, right? They're called bits. But sometimes a little bit of electrical interference, maybe a tiny power surge, can actually cause a bit to flip. A 1 becomes a 0 or a 0 becomes a 1. That tiny change can completely corrupt a file or just garble a message. The network has to have a way of knowing when that happens.
So how in the world does a network catch such a tiny mistake? Well, it uses this really simple but totally brilliant trick called parity checking. Before they start talking, two computers agree on a simple rule, like, hey, every chunk of data we send has to have an even number of ones. So look at the top example. The data comes in, it has 4 ones. That's an even number. Check, it's good. But look at the bottom one. It arrives with 7 ones. That's an odd number. The computer on the other end sees that, instantly knows something's wrong, and just says, hey, send that piece again. It's such a simple and elegant way to keep data accurate. Okay, so let's circle all the way back to our blueprint from the beginning. It should all make a lot more sense now, right? You can see the physical pieces, the switch for internal traffic, the router for getting to the outside world. You can see the star layout, giving everything its own clean connection. And you can picture those invisible layers on top. TCP/IP letting everything speak the same language, and a firewall standing guard. And just like that, you have the whole picture.
So there you have it. We've gone from a few basic parts to understanding this incredible, resilient system that connects the whole planet. That invisible network that's all around you, well, hopefully it's a little more visible now. So the next time you tap your screen and connect to something halfway across the globe, you'll see it not as magic, but as a clever blueprint in motion. Thanks for watching.